Student learning objective: solve a 3 by 3 system of equations using row operations. Here we have the system. There are 3 equations and 3 variables, and our instructions are to solve and write the answer as an ordered triple. To make this a little easier to track, I'm going to call each of these rows by a certain name: row 1, row 2, and row 3. This is a process of elimination. For example, if I do row 1 plus row 2, I would have x plus 2y minus 2z equals 7, that's row 1, and 2x minus 2y minus z equals negative 7, that's row 2. If I add these together, we get some elimination. We can eliminate the y. We get 3x minus 3z equals 0. This is great. So this I would call row 4. Now what's special about row 4 is it doesn't have a y. If we had another equation that didn't have a y, we'd have a little 2 by 2 system, and those are easier to solve. So if we want to eliminate y again, we take a look originally, and if I do row 1 plus row 3, the y's will again reduce. They will eliminate. So let me reset up row 1 and then row 3. When I add these up, I again eliminate the y. To start this process, you need to pick a variable, whichever one you want, and eliminate it twice with 2 different combinations. So this is working out well. X minus 4x is negative 3x, no y, plus z equals 6. This would be a row 5. So let's rewrite what we have now. (3x minus 3z equals 0) and minus 3x plus z equals 6 is our 2 by 2 system, consisting of row 4 and row 5. You can solve this system with elimination, that I will do, or with substitution. It's not that hard. I would never do a 3 by 3 system entirely with substitution because that takes too much paper and too much focus. But here it's not so bad. But it's set up nicely to eliminate. We get negative 2z equals 6. If I divide by negative 2, that's z equals negative 3. All right, we're on to something. We have 1/3 of our final answer. We now need to back substitute. Back substitute into one of the row 4 or row 5s. Don't necessarily back into 1, 2, or 3 because usually they have 3 variables and just knowing one of them isn't enough to find another. But row 4 and 5 have 2 variables. Knowing one of them is enough to find the second one. So for example, we look at row 4. 3x minus 3z, and z is negative 3. That would be plus 9. So that is 3x equals negative 9. X is negative 3. Nice. Now we have z and x. We have 2. We can go to one of the first 3 equations, like row 1. X, negative 3, plus 2y, minus 2z will be plus 6. That equals 7. So this is 2y plus 3 equals 7. 2y equals 4, y equals 2. We have an ordered triplet, negative 3, comma 2, comma negative 3. The fact that it's not fractions suggests that this is probably correct, but there's one way to make sure. Negative 3, 2, negative 3. You would need to plug this in to all three original equations to see if it works. Negative 3 plus 4 is negative 1, plus 6 is 7. The second one, this would be negative 6 minus 4 is negative 10, minus the negative 3 is plus 3 is negative 7. And the last one would be 12 minus 4, which is 8, minus 9 is negative 1.